Hello everyone, and welcome back to another GIS mathematics tutorial video. And in this video, I want to talk about the ellipse. And the reason I want to talk about ellipses is because you'd be surprised how often the idea of an ellipse shows up in GIS, even right down to the way that we describe the shape of the Earth. Right? Globes tend to show the Earth as being a perfect sphere, but in reality, the Earth is actually shorter from the poles to the poles than it is if you were to go around the equator, right? And if you were to cut the Earth in half and look at it, you would see something that looks very similar to this shape right here, right? It's shorter in one dimension than it is in the other. And this sort of squished circle, we call that an ellipse. And so what I want to do in this video is I want to go through what it means to be an ellipse, sort of from a graphic perspective. I want to talk about a couple of key terms that we use in reference to an ellipse. And hopefully in doing that, we'll build a good solid framework for being able to go into the next episode talking about the standard equation. So let's start off by defining what it means to be an ellipse. Right, what does it mean? What makes this blue line special? And in order to be an ellipse, what you end up having is you end up having all of the points whose summed distance from two anchor points is always constant. Right, and those anchor points we call those, those anchor points, we call those focus points or foci. Right, and I used red here because I'm tying directly into our little diagram here. Right, these points right here, this is a focus point. This over here, this is also a focus point. Okay, and so this definition to me is kind of hard to wrap your head around, and so I want to sort of show you graphically what we mean when we say the sum distance from two anchor points, also called focus points, is always constant. What does that actually mean? Well, I think the best way to do that is going to be to go through two different points that are on this ellipse. Let's choose this point right here for fun, and then we'll go ahead and we'll do yellow. Oh, yellow's probably not a good choice. Let's do lime green, right? And we'll choose this point down here. Right. So what it means when it says that the summed distance is always constant, what that means is you can think of this back to when we were talking about Euclidean distance, right? There is a distance in space from this point to this point. Right? This is a distance, and we're going to call this one D1, and I'm going to put a little A here. This is the distance between the first focus point and a point on the ellipse. And then we can do the same thing going from here, right? There is another distance. We'll call this one D2. And I'm going to use, again, a little subscript A. Right? This is the distance from this focus point to the point that's on the ellipse. So we have D1A and D2A. And we can add them up. Right? We simply just add D1A plus D2A. Now, I have no idea what they actually are in this case, but again, just conceptually, right, take the distance from one focus point to the point on the ellipse and the distance from the other focal point to the point on the ellipse and add them up. What makes the ellipse unique is that all of these points, regardless of where I put the second point, right, I put the second point down here. Regardless of where I put these points, this sum is going to always be the same. So what that means is we can imagine that there is another, right? We have this point down here. We can imagine there's another set of distances, right? This set of distances here, right? So from this focus point to this point, we're going to call this D1. Then we're going to call it B, right? And then we have the distance from this focus point to the point on the ellipse, right? This distance right here, right? This, we'll call this one D2B. So what it means for both of these points to be part of an ellipse is that D1A plus D2A has to be equal to, I'm going to put this in white again, has to be equal to D1B plus D2B. So let that sink in for a second. I know this is a little bit confusing, but again, I could have picked any points on this line, taken the distance between this ellipse this focus point and the point on the ellipse, and this focus point and the point on the ellipse. And for any point, right, that sum will always be equal. That's what it means to be an ellipse. And that's what it means when it says the summed distances from anchor points are constant. It means that all of these points, right, any 2 points on this ellipse are going to have this relationship. Hopefully that makes sense. So let's talk about some other key terms. So we have the focus points. I'm going to go ahead and I'm going to erase this here. Erase that really quick. Okay. Because I want to move on to a different term or a different set of things. So you can also imagine drawing a vertical line that splits the ellipse in half up and down, and a vertical line that splits the ellipse top and bottom. So the vertical line splits it left and right. The horizontal line splits it top and bottom. And these sort of lines have their own special names. The one that runs along the longest direction of the ellipse, right? In this case, it's wider than it is tall, right? In this case, this line that runs through it on the long side, this is called the major axis. So major axis is the straight line that cuts the ellipse in half through the longest dimension. All right, so you can imagine if this ellipse were rotated 90 degrees, that the vertical dimension here, if it was taller than it was wide, that this vertical line would then be the major axis. But for right now, because the ellipse is drawn the way that it is, right, this left to right axis is horizontal line, this is the major axis, and then the vertical line, right, that cuts it in half through the shorter dimension, right, this is called the minor axis. So the minor axis, right, that's the straight line that cuts the ellipse in half through the shortest dimension. So this is the minor axis. I think we're actually going to stop the video here because I don't want to just overload you with terms. We're going to stop the video here, and we're going to pick up in the next video, continuing with a few more definitions. So hopefully you were able to follow along with what it means to be an ellipse, right? What this sum of distances being equal means, and the difference between the major axis and the minor axis. If any of this was confusing, I strongly encourage you to go back, rewatch the part you're confused about, and as always, please reach out. Thank you.